Hi students, good evening students. Today I am explaining you photoelectric effect students from the structure of atom. This concept is from structure of atom. Both NEET and JEE mains point of view, very important concept. Especially JEE mains point of view from this area, graphs are very important, graphs especially. This photoelectric effect belongs to S block elements, highly electropositive elements. Inside this concepts existing ejection of electrons, how the electrons are transferred from the metal surface. Here once look at the small concept photoelectric effect, how it is going on. Here this is the metal S block element. For suppose the S block elements are highly electropositive elements, already you know that these are negative charges, that means electrons are existing. So to the metal atom some frequency of light with some energy, the incident light, it is the incident light. What happens, the light is passing towards on the surface of the metal atom. What is going on, what is happening? Incident light, that is white light for suppose, having the some frequency, some energy, some frequency of white light is passes towards the metal atom. What is going on? So from the surface of the metal, electrons or ejection takes place with some kinetic energy Ke. There is a bond breaking between metal nucleus and valence electron, then ejection of electron takes place from the surface of the metal. That is called as simply photoelectric effect. But every light is not break the bond between metal nucleus and valence electron. Particular frequency of light only is possible to break the interactions between nucleus and valence electron, then only ejection of electron takes place. For bond breaking nucleus and valence electron, here the nucleus is present at center and valence electron is present, there is interactions are existing. The interactions for breaking that interactions, energy is needed. But every light different color in the picture, in the visible different lights having different frequency. Every light every light not possible to breaking this frequency. Particular light is possible to breaking that frequency of energy of between interactions between nucleus and the valency electron. Particular light only is possible. So based on that point, particular frequency of utilizing is possible and break the interaction. For breaking that interactions frequency, some energy is utilizes, particular energy is passing from that. Some amount of energy is utilized to break the interactions between nucleus and electron, and some amount of energy is utilized, the electron is moving away from the nucleus, that means as a kinetic energy, away from the nucleus, that is moving as a kinetic energy. So here the formula here, the total frequency of light energy utilized as W naught plus K. Here is incident light energy, W naught is the here work function or threshold energy, work function or threshold energy. So what is E? Already we know that what is the E is equal to H nu. E is equal to H nu. And W naught is equal to what? What is the W naught? W naught is nothing but H nu naught. Substitute these relations in the above relation. H nu is equal to H nu naught plus half mv square. H nu is equal to H nu naught plus half mv square. Half mv square is nothing but what? Kinetic energy. K is equal to half mv square. So H nu is equal to H nu naught plus Ke. So I am writing this equation, Ke is equal to H nu minus H nu naught. Here the nu is nothing but what? C by lambda. Nu is nothing but what? C by lambda. So Hc by lambda minus Hc by lambda naught. Kinetic energy Ke is equal to. What is the common term here? Hc is the common term. Hc 1 by lambda minus 1 by lambda naught. This is the relation kinetic energy and incident light wavelength and threshold wavelength. Lambda is what here? Here the lambda is incident light wavelength. Lambda naught is metal wavelength, lambda naught. K is nothing but kinetic energy, H is the Planck constant, C is the velocity of the light. Already we know that. Planck constant value, what is the Planck constant value? 6.626 into 10 power minus 34 joule seconds. That is the Planck constant value. Generally, photoelectric effect is shown by which elements? S block elements. Why? Because S block elements are highly electropositive elements. They are exhibit photoelectric effect. Uh, Lithium, sodium, potassium, rubidium, cesium. Among them, which is shows the photoelectric effect effectively? Here, the cesium. It readily shows the photoelectric effect. Reason? It is highly electropositive element. It is highly electropositive element. Positive element. It shows the photoelectric effect. Effectively, electron readily loose from the surface, from the valency. So this is the photoelectric effect. E is equal to W naught plus Ke. Ke is equal to Hc 1 by lambda minus 1 by lambda naught. From this data, graphs are there. Different expressions are there. The different expressions graphs are very important. I will teach you in the next class.